BC for response 5. Consider the differential equation dy dx equals 3x plus 2y plus 1. Timeout, pause. This is non-separable. The x's and y's are being added. They can't be factored into some kind of multiplication or division. So no matter what they ask you to do, they cannot possibly ask you to solve this diffie cube. Cool. Time back in. Part A. Find d squared y dx squared in terms of x and y. Okay, so for part A, d squared y dx squared, which is what happens when we derive this side, equals derivative of 3x, which is 3, plus the derivative of 2y, which is a 2 dy dx, because I'm deriving with respect to x, right, plus 0, which is gone. Now, this isn't wrong, but it's not in terms of x and y. What I need to do is I need to use this thing to replace this thing. So I'm going to get that this is a 3 plus a 2 times this whole quantity, 3x plus 2y plus 1. And if you want to leave it like that, that's fine. If you want to clean it up and distribute, that's also fine. If you choose to clean up and distribute, you're going to get a d squared y dx squared equals, you're going to have a 3, 6x, 4y, and a 2. So you're going to have 6x plus 4y plus 5, right? And that's just fine. I would argue that you could have also left your answer right here. That's totally fine. It just needed to be in terms of x and y. Part B. Find the values of the constants m, b, and r for which y equals mx plus b plus e to the rx is a solution to the differential equation. Good times. All right, so right now we don't need d squared y, so we're going to dx squared, so we're going to get rid of that. Okay, so in part B, they can't ask you to solve a diffie cube that's non-separable. They can tell you, hey, this thing is a solution. Find out things about this solution. So they're telling you that this value is a solution to that differential equation. So dy dx for this thing, the first derivative, would be equal to an m plus re to the rx, right? So that's what we know. So we know y, we know dy dx. Okay, so if I were to plug back into these, this thing on this side, right? So if I take my differential equation, what it means to be a solution to the differential equation is that for every x and every y, if I replace dy dx with this stuff and y with this stuff, then I'm going to get a value. So that means that this left-hand side, dy dx, can be replaced by this, m plus re to the rx, right? And the right-hand side is a 3x plus 2, and then in place of the y, I'm going to put an mx plus b plus e to the rx plus 1. Okay, so it's not as bad as you think it is, I promise. So here's the idea. Let's clean this up a little bit. I've got an m plus an re to the rx, right, equals, when I clean this up, I seem to have a 3x plus a 2mx, those are my x's, right, plus a 2b plus a 2e to the rx, all plus a 1, right? So let's keep cleaning up a little farther. M plus re to the rx equals, if I look at just the x terms, I get a 3 plus 2m in front of the linear x, right? If I look at my e stuff, I get a 2e to the rx, right? That's the only e stuff. And if I look at my constants, I have a 2b plus 1. Here's the trick. To be a solution to the differential equation, whatever's on this side has to equal whatever's on this side regardless of x. What that means is that the x stuff has to equal the x stuff. Well, there's no x's on the left-hand side, right? So if we come up here for a sec, and I'm going to buy myself a little bit of space actually up here, okay? So whatever's on the left-hand side has to equal whatever's on the right-hand side. So the linear x term on the left-hand side, which doesn't exist, has to equal a 3 plus 2m on the right-hand side. Well, that gives me enough information to be able to solve for m, right? So I can take this, subtract the 3 over and divide by -2, and I get, or divide by 2 rather, and I get -3/2 is my m, right? Similarly, right, if I look at the e to the stuff term, right, like the e to a power term, right, the e terms, right, the e to some exponent, and in fact we can even call it the e to the rx term, the re to the rx has to line up with the only other e to the rx term, which is a 2e to the rx. Well, that must mean that r equals 2, right? Because, again, the e to the rx terms have to line up, so r has to be 2. Cool. And then the last one is that whatever constants I have on this side have to line up with the constants on this side. Well, the only constant by itself on the left-hand side is an m, and on the other side I get a 2b plus 1. Now, that might seem daunting at first, but if you remember, we already found m, right? So m was a -3/2. We'd subtract the 1 over, so -1 equals 2b. I seem to get that 2b is a -5/2, which means that b must be a negative 5/4. So I now have m and r and b, which is what I was asked to find. Now, there is another possibility. So that's one of two possibilities. There are two. The other possibility that we didn't address here is if r were 0, it doesn't matter. So in these e terms, if r is 0, they're both going to be the same. So there is another possibility, and the other possibility is that e to the rx is 1, right, because r is 0. And if r were 0, that's going to change the value of b. So let's talk about that. So this is one possibility for my values. There is one other possibility. So my first possibility was negative 3/2 equals my m, r equals 2, and my b was a negative 5/4, right? But we have one other possibility, and it's only because we have this exponential here. So there is another possibility. The other possibility is that if r is 0, then e to the rx, right? So if r is 0, if r equals 0, then e to the rx is a 1, right? Which means that these are actually constant terms. So if r is 0, then what this equation actually looks like instead is m equals, because this is all be 0, equals a 3 plus 2m times x plus a 2 plus a 2b plus 1. And then if r were 0, we'd actually get the same m. M would still be the negative 3/2 because there's still no x on this side. But if r were 0, we'd now get that negative 3/2 equals a 2b plus 3 because now this is a constant. And so we end up solving and getting negative 9/2 equals 2b. So b would be a negative 9/4. So the two possibilities are that m is a negative 3/2 either way, but if r is 0, it would change b to a negative 9/4. So there are actually two possibilities for this, right? What's worth noting here is they said find the values of the constants, right? They didn't actually say you had to find both scenarios. So the reason I did both scenarios here is to show you that either of these answers would have been acceptable. So if right away your first thought was, yo, if r is 0, then what's going to happen is that this is actually a constant, that's great. You would have gotten this answer. If your first thought wasn't to see that, you would have gotten this answer, and either of those would be fine. All right, part C. Let f of x be the particular solution to the differential equation with the initial condition f of 0 is negative 2. Use Euler's method starting at x equals 0 with step size of a half to approximate f of 1 and show the work that leads to your answer. Okay, so Euler's method, I know I say this in every video, but I do Euler's method as a table. You don't have to do Euler's method as a table, but that's how I do it. So here's what I know. I list my x, my y. I know the slope is 3x plus 2y plus 1, because that's my dy dx. And I know that to find my new y, I'm going to take the old y plus the slope times the change in x, right? Which in this case is a half. So I'm told that f of 0 is a negative 2. I'm told to use increments of a half to approximate f of 1. So this guy right here is going to be my final answer. I also know, because of that, that my change in x is a 1/2, right? So if I scooch that over, my change in x is a 1/2. So I use the first point to find the slope. So the slope at this first point would be 3 times 0 plus a negative 4 plus a 1, which is a negative 3. So I use my old y, right? My new y is my old y, plus the slope, which was negative 3, times the change in x, which is a half, right? So that's going to be a negative 2 minus a 3/2, right? Which should be, you can either think about it as negative 2 minus 1.5, which is a negative 3.5, or you can do it in fractions. It doesn't matter. I get a negative 7/2. After I get my negative 7/2, that's my new y value, right? And then to find my slope, I use 3 times the x, which would be 3/2, plus 2 times the y, which would be a negative 14/2, plus a 1, which is a 2/2, right? Since everybody seemed to be in halves anyway. So I think I get negative 9/2, right? So that's a negative 9/2 for my slope. Once I know my slope, I use my old y, which was negative 7/2, plus my slope, which was negative 9/2, times my change in x, which is a half, right? So I end up getting negative I'm going to go ahead and make this into fourths because I can see this guy's already fourths. So I'm going to make negative 14 fourths minus a 9 fourths. So I get negative 23 fourths, and that's my answer here, right? That's my new y. So my answer is that f of 1 is approximately a negative 23 fourths. Now on Euler's problems, they give you credit for showing you did Euler's twice in case you accidentally added wrong. If you get crazy giant numbers or horrible, horrible fractions that aren't like thirds or fourths or halves, take a deep breath and think, hey, I probably added or multiplied wrong. Let me go back and check my work. All right, finally, part D. Let y equals g of x be another solution to the differential equation with the initial condition g of 0 is k, where k is the constant. Euler's method starting at x equals 0 with a step size of 1 gives an approximation that g of 1 is 0. Find the value of k. Ooh, this is fun. So this is an outside-the-box kind of Euler's question. Okay, so here's what we know. We know that we're going to do Euler's, right? We're going to set up our little Euler's table. So x and y. Okay. And my slope is still this 3x plus 2y plus 1, right? And I know that my new y is my old y plus my slope times the change in x. Now, here's what they told us. They told us that g of 0 is k, right? They told us that if we use Euler's method with a step size of 1, so we're only doing one round, right? The step size is 1. We're jumping right here, that we end up getting the answer is 0, right? So I'm going to go ahead and find my slope, right? My slope is going to be 3 times 0, which is gone. So my slope is going to be 2k plus 1, which means my new y, which by the way is a 0, should be the old y, which was k, plus my slope, which was a 2k plus 1, times the step size, which is 1. So this new y value should be a 3k plus 1, right? So 0 equals 3k plus 1, because they told me this new y value is a 0, so k should be negative 1/3.